I'm back. And yeah, it's been a minute. I don't even know what I'm doing with my life anymore. I'm failing physics. Everything's going horrible for me. It's terrible, terrible, terrible. I don't even know if this thing is on. Is this thing on? Hold on. I don't want to change my widgets. Yeah, this thing's on. But we're here with another video, guys. I am so tired. Honestly, it's been a minute. I'm sorry I haven't uploaded in over a month. Y'all probably hate me. Please do not subscribe. I promise I will be following the schedule more. We're going to go through an interesting topic today. And it might be like a little series part depending on if I want to do it with Calc 3 or Calc 2. We're just going to go over converting polar coordinates today. Essentially, you know that in normal Cartesian math, you have the y-x system where you have, let's just say this is, I don't know, like 5, 5, right? So in the normal Cartesian xy system, you will have a point 5, 5, and then from there you go 5 to the right and 5 up. Or if it were to be negative 5, 5, you would go negative 5 to the x, so it would be right here, and then 5 up. However, the polar system is very, very different in terms that it deals with a radius and more with circles. It deals with more with circles, really. So instead of dealing with, in reality, x, y, it has the x and the y telling you where to go. Polar coordinates are a little bit different. They have this thing called r and then theta. Essentially, r is just the radius or the distance from the origin that you want to go to. So let's say it was like right here, right? Theta is just a direction at which the angle is going to be where the distance is going to point at. So right here will be our angle theta. And so right here, I don't know what that point would be. It looks about 45 degrees. Let's just call this radius 5. This would be 5 and then 45 degrees for theta, or I believe pi over 4. Yes. Yes. That will be your theta because it's 45 degrees. Essentially, you're able to convert with between polar coordinates very, very easily. And so I'm going to be showing you how to convert some. So here we go. We're going to start out with the 0.33. In normal coordinate systems, it would look something like this. I'm just drawing the line, just so it can help me more. Essentially, there are two very important things you need to know. First off, theta, or to find the angle, is always equal to the arctangent of y over x. I believe the reason why that is, and I might be wrong, but who knows? I believe the reason why that is because when you have tangent theta, and you know that's just opposite over adjacent from this angle, you get 3 over 3, which tangent theta is equal to 1. From there, you can do arctangent and actually find the angle itself from there, which is just what we're doing with this example. So that's my theory as to why we use arctangent. And then the next one we're going to do is, since it operates off a radius or a distance, we're going to find the distance. So the next equation we're going to remember is r is equal to x squared plus y squared. We're going to use those two equations and find our r, theta, and draw a polar coordinate system. From here, since we know they're both the same thing, we can do arctangent of 3 over 3 equal to arctangent of 1. Essentially, arctangent of 1 is just the inverse operation of tangent theta is equal to 1. And so we're just saying what angle does tangent theta make that could be equal to 1? So we go to our unit circle and we see, oh, pi 4. Pi 4 makes an angle with 1. The reason why that is because The x and y are the same. When you do tangent theta of it, you do theta over 2 times 2 over theta 2, and it cancels out to 1. That's why it's pi over 4. So we know it's going to be pi over 4. And now we can take the distance of it. We know it's going to be 3 squared plus 3 squared. And that's essentially just, let me see my math is right, root 18. So for this one, we can say that the polar coordinate system, the coordinate would be root 18 with a theta of pi over 4. You could probably, what's it called? You could probably like simplify that radical, I guess. You can do 9, 2, keep that, root this. Yeah, you could do 3 over root 2, pi over 4 for your coordinate system. We're going to go to our second example. We're going to go to -4, 4 root 3. This seems a little bit hard, and I'll tell you why. It's not hard per se. However, it's sort of willy-nilly. And if you get my vibe, you get my vibe. Here's my thing. You have to look at the normal Cartesian system before you do this. Here's what I mean. Essentially, we have -4, which is right here. Let's just say this is -4. Going up, which is 4 root 3. However, and I'll show you this, when we do our arctangent to find our theta, you'll see that we'll just get -√3. The reason why this is kind of difficult is because you're trying to look for the point where the theta makes sense. If you type in, I think, arctangent of -√3, you will get around an answer of -60 degrees, I believe. Simply because the calculator doesn't know where you're calculating in the second quadrant or in the fourth quadrant. So whenever you're calculating for polar coordinates, you have to be extremely careful about the quadrant you're calculating in. When we do -√3, we're going to get the answer of 2 pi 3 being your theta. The reason why that is because at 2 pi 3, you have -1/2 root 3 over 2. Root 3 over 2 times -2 is equal to -√3. Make sense? It's this whole theta. From here, we can find our distance, which is r is equal to, I'm going to just make the simplifications. 4 squared is 16, plus -4 root 3 squared is 16 times 3, which I believe is 48. This actually simplifies down to, I think, 64, which is actually equal to 8. So it actually all works out at the end. And that is our polar coordinate. Obviously, you can plug these in and then find what you need, but I'm just converting to polar coordinates as of right now. That'll be in a different video. For our last example, we are going to do this interesting one, 0, -5. This is very interesting because the polar coordinate is around right here, 0, then you go 5. So your r is going to be around here. That's not a vector, by the way, if y'all get confused. This is going to be very, very interesting. When you try to do the arctangent of -5 over 0 is equal to theta, you don't get an answer exactly because you can't really divide by 0. There's a solution to this, though. Since we know that the angle here is going to be in the negative y-axis, but x is equal to 0, if you know your unit circle really, really well, you can just trace back over here and know that this theta, or this angle, is just 3 pi over 2. Let's say we had 0,5 as well. We know that 0,5 is around here. And for this one, it'll be the same situation. You'll have arctangent of 5 over 0 equal to theta. However, since we know that this angle right here, this theta, is 90 degrees, we know that this is pi half, the angle. So therefore, our theta for this one, for 0, -5, is theta is equal to 3 pi half. From here, we can find our distance. R is equal to 0 plus 25, because 5 squared is 25. And we give that R is 5. So therefore, our polar coordinates for this one is 5 and 3 pi half. And that is a way in order to convert from normal Cartesian, I think, into polar coordinates. Thank you for watching. Again, this is just like a video to get back in the groove. It's been a minute. I'm sorry for not uploading. However, I will do better for my time management later. Thank you for watching, and thank you, and goodbye.